Okay, so this video starts from sum number 16. An ice cream cup is designed in form of a right circular cone. The volume is given to be 150 centimeter cube and the vertical height is 14 centimeters. Find out the radius of the circular base. You don't, yeah, very good. But you know the volume. So can you use the volume formula and find out the unknown?
V equals to 1/3 pi r square h.
I don't know this why these things are coming and it's not minus. Okay, so volume is given 150. You substitute? 150 is equal to 1/3 pi r square, and h is how much? Where the gibberish things are coming? I don't know.
14.
So solve n. It will give you 3.1986. So 3 significant figures, this will be how much?
3.2.
3.20. Okay. Slant height. Now can you get the slant height?
L square equals to 14 square plus r square.
3.9189 square. So L 14.36. So 14.36 means 14.4. Correct? So in mid of the calculation you have to take all significant figures and final answer should be 3. The curved surface area? What's the formula?
9
Pi RL. Yeah, very good. So take here you have to take all. 3.1986 and 14.3 something you said.
14.360.
360. 36.
144,299.
So 144. That's the curved surface. So container in shape of a right circular cylinder as shown in the diagram. The height of the container is 5 and the diameter of the cylinder is 8. Correct? The cylindrical base is 8. Find the volume of the container.
Volume of sphere. No, container cylinder, no? So volume of cylinder. V equal to pi r square h.
So pi, what is the radius?
8.
No.
4.
Yeah, don't forget that. Huh? Don't mess that up. R square 2 into 5.
8 to pi.
So convert that to decimal.
251.32.
So 251. Correct?
3 to 7.
3 significant figures. Then a cup full of water in shape of a hemisphere shown right above. The water from the cup is poured into the container and fills 1/3 of the container. Find the radius of the cup.
No need for the volume.
So what is the volume of the cup?
The sphere, no?
Hemisphere.
But there's no hemisphere formula.
Hemi is half. So volume of the sphere is there, you half it.
So V equals to 4.
Half of 4/3 pi r cube. So basically it will be 2/3 pi r cube. Correct? Now the volume will be how much? It says fills 1/3 of the container. So volume of the cup is 1/3 of the volume of the cylinder. What is the volume of the cylinder? No, don't take 251. Take more significant. 0.324 is equal to 2.3 pi r cube. Solve it. Do solve it fully.
Oh, fully.
3.4. Yeah, so radius how much did you get?
3.4199.
A loaf pan is made up of the shape of a cylinder. The pan is a diameter of 24 and the height is 5 meters. Calculate the volume of this pan. So what is the formula volume of the pan?
First radius is 12.
First radius is 12. So volume will be pi r square h.
Equal to pi r square h.
So pi into 12 square
12 square.
into 2 into 5, sorry. So 2262 centimeter cube. Then Gloria prepares enough bread dough to exactly fill the pan. The dough was in shape of a sphere. Find the radius of the sphere in centimeter correct to 1 decimal, please.
Find the height of the sphere.
Spheres don't have height.
Volume, sorry.
Volume of the sphere?
4/3 pi r square.
Pi r cube.
Cube, sorry.
So you have to find the radius. What is the volume of the sphere?
24.
2262, no?
That's the volume.
The volume
of
of same thing.
the
So
pan.
the dough
It's
is,
a cylinder.
pan is a cylinder, but the volume, the dough is filling up the pan fully. No?
Okay, so it'll be wait. So this all then 2262 equals to
No, don't use 2262, please.
261.
Point
0.946 equals to
pi r cube.
4/3.
4/3 pi r cube.
Yeah.
Solve in 8.143. So radius is equal to 8.14 centimeters. Correct? Now, the bread was cooked in hot oven. Once taken out of the oven, the bread was left in the kitchen. The temperature of the bread in degrees Celsius is modeled by this function. This is a function which is given. Okay? Where A is a constant, T is the time in minutes since the bread was taken out of the oven. When the bread was taken out of the oven, its initial temperature was 205. The moment it's taken out is 205. Find the value of A. What information does this give you?
It gives you the time, it gives you
the temperature. So basically, this tells you when time is equal to 0. The moment it's taken out, then time is 0. The temperature is 205. So you substitute that. So in this 205, I'm putting in this equation.
205 equals to A into 151.
1.151 raised to 0 minus T upon 3 it is.
So minus 0 upon 3.
So that's 0
plus 21.
plus 21. So you solve for A.
Now you substitute
184.
You substitute 10 for 10 upon 3.
Now find a temperature of the bread 10 minutes after it's taken out of the oven.
So you put
so
0,
temperature
your
10.
X becomes 205 in this, and your this thing.
No, not 205. This is your 184.
Yeah, that's exactly
1.51 raised to minus 10 over 3.
Yeah.
Correct. Plus 21. Means you got the value of A, no?
Yeah, that's what I meant.
Okay, that's what you meant. Okay, good.
67.583.
60?
7.583.
So 67.6. 67.5 and 67.6 degrees Celsius. Then the bread can be eaten once its temperature drops to 35 degrees Celsius. Calculate the nearest minute the time since the bread was taken out of the oven till it can be eaten.
Which bread?
This same bread. Same model here.
Okay.
It's the
So
same.
your t would be, the small t would be x.
Yeah, small t
So
is your
say
variable. So
yeah.
capital T will be
Yeah,
35. That's your temperature. Is equal to 184. You're finding the small t. 151 minus t over 3 plus 21. And you solve for small t. So 18.8 minutes. Nearest minutes. So 19 minutes. 18.8. So that's 19 minutes. Nearest minute they want. So 19 minutes after it's taken out of the oven, you'll be able to have it. In the context of the model, state what 21 represents. What does this 21 represent? There's a room temperature. There's a room temperature. I'll tell you. See, what is happening is this is an exponential decreasing function. The moment you take out of the bread, 21 is the room temperature, it will decrease. Keeps on decreasing till it will never touch 21. So 21 is your horizontal asymptote. So no matter how long you keep the bread, it will never attain 21. Theoretically.
But realistically.
Yeah, realistically it will be little. A large plot of land is shaped like a trapezoid, where AB is parallel to CD. Correct? AB is 12 kilometers. CD is 8 kilometers. The BD of a trapezoid is equal to 10 kilometers. The internal angle ABD is 58 degrees. A new point H to be on AB closest to D. Calculate the distance of H to D.
Where is H?
Now remember, whenever they say closest, no, is a perpendicular distance, because when you drop a perpendicular distance, because see, if you take any other distance, no, it will be more than that. See, your hypotenuse is always bigger than the right angle, basically. This side. So remember, the perpendicular is the shortest side. So what will I do is I drop a perpendicular. Now that may not be a perpendicular bisector because it's not an equilateral triangle or isosceles triangle. So it may be slightly offset. So that's your point D. H, I mean. So what will you do? How do you find DH?
D equals to square root of x1 minus.
No.
Different distance.
Can you use trigo?
Yeah. I thought it was
Sine 58. You remember sine opposite side?
What
Opposite
it
side.
explains SOHCAHTOA.
SOHCAHTOA, yeah.
What is sine cosine?
Okay, let me just explain you. 1 second. Why is this not writing? DH upon 10. See, when you have a right angle triangle, if this is theta, this is opposite to theta.
Opposite absolute.
This is hypotenuse.
Hypotenuse and
Adjacent. So when you do SOHCAHTOA, your sine is opposite side upon hypotenuse.
So you're finding adjacent.
No, you're getting an equation. Okay, sine theta. Suppose if I call it ABC. Sine theta is equal to A upon C. One unknown has to be there.
Okay.
Acha, what is your cos theta?
Adjacent hypotenuse.
So what will that be in terms of the letters I have written?
BC.
B upon C. What's your tan theta?
Opposite adjacent AB.
So A upon B.
And inverse.
So one unknown has to be there.
Yeah.
So sine 58 is the opposite side.
So 12.
So sine 58. So this is the opposite side.
Opposite
And the hypotenuse.
So 12 over 10.
So DH is equal to now 10 multiplied by sine 58. So do it on your calculator and tell me the answer.
8.480.
So 8.48.
Zero.
So I won't write 0. Okay. Now what do you do? Next one. B. The length of AD. How do you find length of AD?
Same triangle now.
See, this 10 was, this was 10. Huh? This was 10. This is 10 kilometers.
That is 8.4.
Now, this is your 8.4, your vertical height. Now, how do you find out AD? Can you find out HB?
It's 12. No. That's 80.
Can you use cos?
You can find out HB.
Cos, can you use cos?
Yeah.
What will cos 58 be?
Cos 15 equals to
58 is equal to HB upon 10. Correct? Because cos of this angle is adjacent side upon hypotenuse. Or 5 point, take more significant figures. 5.299919. Well, take more 4 5 significant figures. So what will AH be? This is what we got. What will AH be?
12.
12 minus 5.29919. You're following that? This whole length minus this much.
3.51.
How can it be 3.5? 12 minus
6.7.
so in the bracket it doesn't solve it, solve it doesn't work. 6.7
0, 0.
0081. Let's leave it this way only. So this is your 6.70081.
So now that's always my hypotenuse.
Yeah, you can find only AD.
AD, so wait, so cos theta.
So AD square is equal to 6.70081 square plus 8.48 square. Take more significant figures, that will give you AD.
Why are you doing distance formula?
Pythagoras theorem, no? Hypotenuse square, this is a hypotenuse square, is equal to base square plus height square. Hypotenuse square is equal to base square plus height square. 10.80. Next, calculate the size of angle DAB. What is the size of this angle B? DAB. So can I do?
Wait.
So let's call theta. Correct. So tan theta is equal to 8.48. Take more significant because I don't know what the numbers were. 70081. Or you can solve it also. Yeah, tan inverse open brackets and get it.
Open brackets 8.48.
Is it 8.48? Take more significant figures. I don't know. You look at your calculator.
6.7.
6.7?
008.
No, upper also you will take 51.7 degrees.
8.4804. Hmm. 51.6.
So 51.7 degrees. Now, a landowner estimates that AD is equal to 11.5. So, what is the percentage error? So, the estimated value, look at the percentage error formula. The first part, estimated values
minus VE upon VE into 100.
Percentage
V is the exact value and VA is approx value. So it will be 10 point
VA
10.
minus VE upon exact value, correct? V is exact.
So
exact value is how much? Exact value is how much?
10.28.
No, take more significant figures.
That was it, sir. 10.
No, 10.8 something it was. 10, there is gone. Yeah. Down. Yeah.
Right, sir.
You missing it out.
10.8079.
10.8079 minus 11.5
upon 10.8079.
upon estimated upon 11.5.
No.
See the formula.
No, it's exact and
exact, no?
So exact is
exact. Exact is 10.8. 10.8079. You're right. You made a mistake. This modulus means you don't have to take the sign.
6.40.
So 6.40, so 6.40%. Correct? The sum is not yet over. The landowner decides to install cone-shaped concrete bollards along the perimeter of the plot of land. The bollards are to be installed at a distance of 100 meters each. The radius of the base of each bollard, you know what a bollard? Conical bollards like this. You know, in traffic and all that they put those cones like this. So these are conical bollards. Okay? Conical bollards along the perimeter. You also put bollards like this along the perimeter, along the boundary. Okay? The bollards are to be installed at a distance of 100 meters from each other. From the center of this to center of this, I presume. From each other means, or this is 100 probably. This is 100 meters from each other. From the end to end is 100. I think so they are referring to that. It's not very clear. The radius of the base of the bollard is 20. The radius of the base of the bollard is 20. And the height of the bollard is 40. Calculate the volume of one bollard.
Pythagoras theorem.
Volume!
Oh, V equals to
1/3 pi 20 square into 40.
Oh yeah, right.
Sorry, what is it?
16, 17.
Yeah, whatever it comes out, that seems quite a big number though. So this is centimeters. Yeah, what is the answer? You just give me a calculator. 16755.16. No, it's right then. If that's the answer, what you substitute in the calculator only. Then the total volume of concrete needed to install all the bollards.
Into 3.
No. Now you look at the perimeter, not into how do you know 3 bollards. That I have drawn 3.
Oh.
You are keeping it along the perimeter. So you have to find all this distance. You got this distance. Now can you find out this distance? This distance? This distance? You have to find all the total distance. Now how do you find out BC? Tell me. Now to find out DC, you can say this is parallel to this. So if this is 58, this will be 58. Correct? You drop a perpendicular here. You drop a perpendicular because it's an isosceles triangle. They haven't mentioned it. Trapezoid parallel this. The diagonal is equal to 10 kilometers. Diagonal BD is 10 kilometers. Correct? So it looks like an isosceles. They haven't mentioned anywhere. There's something. So we have to assume it. I'm assuming this is, so that means if this is 10, this will also be 10. How much did we get your AD as? 10.8. Correct? So what will the perimeter be? What will the perimeter be? Add all the boundaries, no? Perimeter is simply length of the outer boundary. This plus this plus this plus this. That's your perimeter.
So 18 plus 12, 30.
So 8 plus 10.8 plus 10, correct?
Plus 12.
Plus 12. Do that on your calculator. How much is it? The 20, 30, 40.8.
Wow.
40.8 kilometers. 40.8 kilometers. Now, this is all in 40 centimeters. This is 20 centimeters. Correct? Acha, now how much space will one bollard take from here to here?
100 meters.
No, from here to here, if you take it 100 plus 100 plus, you have to take from the start of this bollard till the start of the second bollard. The 100 is between the two bollards. And how much is this from here to here?
20.
40, no? Radius is
20.
but you have to take from here to here. No?
Okay, so for 140.
So 140, correct? Because this is 20, 20 and 100. Yeah? So one bollard is 140. One bollard from start to the start of the next bollard is 140 meters. Oh, sorry, I made a mistake. There's centimeters there. So you have to do, this is 100 meters and this is centimeters. Correct? So it will be 100 plus 0.2 plus 0.2. You have to convert your 20 centimeters to meters. You divide by 100. 100.4 meters is from one bollard, start of one bollard to start of the second bollard. What is the perimeter we got? 40.8 kilometers. So convert 40.8 kilometers to meters. You multiply by 1000. So 4800, 40,000 meters. You jump the decimal, 3 places. When you multiply by 1000, you can use your calculator, but 1, 2, 3. Divided by 100.4. So how much is that? So that will give you the number of bollards. So 406.3. Now you can't have 0.3, so that's okay. So 406 bollards you need. And how much one bollard required? We all, one bollard required this much concrete, no? So multiply that by 17.16. Multiply that. One bollard required so much concrete. So you require, you can take 407 bollards also, because you can round up. But extra distance here, they will be closer there.
6802594.
680
2594.96
units centimeter cube. Correct? All this is centimeter, no? Centimeter, centimeter. So centimeter cube. So much would be required. See, this one, they've used the cosine rule to get the perimeter. You have to get the length of BC. So this is not isosceles triangle. So to find the length of BC, we use cosine rule. So your BC square is equal to 8 square. You remember cosine rule? Open your formula booklet. Plus, how much is this? 10 square. Correct? 8 square plus 10 square minus 2AB minus 2 into 8 into 10 into cos of the angle between them into cos of 58. So work this out. BC. BC is equal to 8.9. How can be 8.9? 8.900. Okay, 8.90. They must have got that only. Because now, so the perimeter would be what? You add all this. So perimeter, you add the boundaries as I told you last time. Correct? You add 12 plus 8.9 plus 8 plus 10.8. That's how much? 39.7. Now here also they've taken this as a distance from the center to center, which wasn't clear in the sum. You know, so this is the distance, not 100 like this. The 100 is the distance from center to center. So this.
So the only thing that would change
is
would be
you take 100. You'll be divided by 100 basically.
Okay, that's not okay.
Because that 0.2 will go basically. So one bollard. So 100.
408.
So one bollard is 100. Correct. So we had how much? How much did we get the distance? How much did we get a perimeter?
40800.
No. We got perimeter 39.7 kilometers. This is no. So you convert that into meters. How much is that? We got the perimeter 39.7 kilometers, which is how much? 39700. Correct? Meters. So number of bollards would be 39700 divided 397. So 397 bollards would be required. 397. So the volume of the concrete required. Volume of the concrete required will be what? 397 number of bollards into the volume of one bollard. What is the volume of one bollard? 16755.16. Here 6.65 into 10 is to 6.65.
How 6.65?
Into 10 is to 6. This is what my OneNote gave me.
6651798.
Yeah. So that's rounding well off.
So I have to.
Now, a right cylinder has height h mm, correct, and diameter x mm. The volume of the cylinder is 45 millimeter cube. The total surface area of the cylinder can be expressed as this. They've given you. Find the value of K. Okay. So what is the total surface area? What did I tell you? Whenever you're doing surface area, imagine you're painting it. So how many surfaces are you painting?
1, 2, 3.
3. What is the bottom?
My teacher's come.
What is the bottom?
X.
Radius is x upon 2. What is the area of the bottom be? What shape is the bottom?
Circle.
Circle. So area of a circle is what? Pi r square. How many such circles are there?
2.
2. One above and one below. Correct? Plus the side.
K.
Nine. Cylinder. Surface area of the cylinder. You imagine you're painting it, not volume. Surface area.
2 pi r.
So 2 pi r is x over 2 and h is h. So when you simplify this, pi x square over 4 into 2 plus 2 and 2 cancel, pi xh. Correct? So this and this will cancel out. So pi upon 2 x square plus k upon x. Now where is the k upon x coming? The pi xh. Correct? Now you equate. This is equal to this. Pi xh is equal to k upon x. Cross multiply to get the value of k. Correct? So pi x square h is equal to k. Cross multiply. The value of k they want. The volume is given. No, sorry, I didn't read this. So we have to use the volume. Okay, not this. This is incorrect. Volume is given. I just saw it. What is the formula of volume?
For
Cylinder pi r square h.
pi r square.
What is the volume going to be?
45
is equal to pi r square x over 2 square into h. Yeah, you won't get it. There are two unknowns.
Oh.
So 45 is equal to pi x square over 4 into h. So cross multiply. 45 into 4 upon pi x square is equal to h. So that's how much? 180 pi x square is equal to h. Now put that over here. Put this value h here. So what is that? Pi upon 2 x square plus pi x. What is your h?
180 pi x.
X square. Pi cancel. Pi will cancel. One of the x cancels. Yeah. So this is the right thing. So what's the value of k?
180.
Okay, is equal to 1. Find the value of x that makes the total surface area minimum. You graph it. You graph this and see where it comes minimum. So graph on your calculator. If you graph this equation in y1, we'll get a graph. You obviously consider the positive side. You don't have to look at the negative side because the x is the radius. It can't be a diameter. It can't be negative. And then you do g solve minimum. You'll get this value, and this 3.86. So the total surface area will be minimum as 3.8.